Hi students, welcome back to our chemistry classmate. In today's video lecture, I would like to explain about some important expected models from electrochemistry, especially on Nernst equation. You know, Nernst equation numericals are very important for any entrance examination. So here I shall try to explain some important models. So as per my textbook, look at the question number 176. The standard electrode potential of the two half cells are given below. So nickel plus 2 to nickel E naught value given, Zn plus 2 to Zn E naught value given. The voltage of cell formed by the combination of two half cells would be. So here before starting the numerical I shall explain small concept. So first of all Ni plus 2 to Ni plus 2 to Ni. That means it is a reduction reaction. That means this E naught value is a SRP value, standard reduction potential value. So this we can reminding as E naught of Ni plus 2 by Ni equal to minus 0.25 volts. Is it okay? Similarly, Zn plus 2 to Zn. That means so Zn plus 2 gives Zn. This is also reduction only. E naught value minus 0.77 volts given. That means E naught of Zn plus 2 by Zn equal to minus 0.77 volts. So these two values given means both are standard reduction potentials. Okay. So in this kind of questions, what is the formula we are supposed to use? Do you know? EMF of the cell equal to E of cell equal to E naught right minus E naught left. Means EMF of right half cell minus EMF of left half cell. So here I shall give small clarity. Just imagine this is the galvanic cell. First half cell and second half cell both are connecting with salt bridge, and both electrodes. This is we can take zinc electrode, and this is we can take nickel electrode. Both are connecting with galvanometer. Okay, so zinc is acts as a acts as a anode, and nickel is acts as a cathode. So in this left half cell, Zn converts to Zn plus 2. In right half cell, nickel plus 2 converts to nickel. So what is the overall reaction? Zn plus nickel plus 2 gives Zn plus 2 plus nickel. Is it okay? So this is a simple galvanic cell construction as per the given question. So here left side oxidation and right side reaction. That means in anode, this is anode, it acts as an anode. Here oxidation. So Zn to Zn plus 2 oxidation number increases. Nickel plus 2 to nickel oxidation number decreases. So here this is cathode reduction. So in this kind of questions, remember that both electrode potential values, they are given in the standard reduction potentials. That is why you can use the formula E right minus E left. Otherwise we can take that E of cell equal to E naught of cathode minus E naught of anode. Is it okay? So as per that, it is a simple substitution. So if you are aware about this concept, numerical solving is very easy. Now E equal to E cathode, E naught of cathode value how much given? See there, 0. minus 0.25. That means nickel value minus oxidation means anode, E naught of anode. Anode value how much given? Minus 0.77. So then what get here? Minus 0.25 minus into minus plus 0.77. If you simplify, you'll get plus 0.52 volts. That means zinc and nickel galvanic cell can produce a 0.52 volts by these values. Is it clear? So very simple model. So here concept also reminded to you. I hope you understood clearly. So then what is our option here? Plus 0.52. Is it okay? Right. Look at the next question. Electrode potential for the following half cell reactions are. So here also, before solving these kind of numericals, first observe whether they are given SRP values or SOP values. So here if you observe that Zn to Zn plus 2. Zn equal to Zn plus 2 plus 2 electrons, nothing but Zn to Zn plus 2. This is oxidation reaction. That means this meaning is what? E naught of Zn by Zn plus 2 equal to plus 0.76 volts given. But as per the EMF series, it is my suggestion is whatever the standard EMF values given, first to convert them into their SRP values. So if you convert it into SRP values, what will get here? E naught of Zn plus 2 by Zn. That means minus 0.76. Then we'll get as per the EMF series. So EMF series way, if you remember, these numericals are very easy. You will not get any confusion. Is it okay? So this value given in the question, but we are converting into EMF value, means SRP value, standard reduction potential value. Similarly, Fe gives Fe plus 2. This is also oxidation only. This is also converting into E naught Fe plus 2 by Fe. What will get here? Plus 0.44 given. Now what will get here? Minus 0.44 will get. Now both are in the SRP values. Now both are SRP values. What is the formula? Just now I said to you, EMF of the cell is equal to E right minus E left. So here again one question arises, which will take E right, which will take E left. So right nothing but if both are SRP values, which is showing the highest negative value, that is E left. Okay, EMF of the left half cell. Highest negative potential left half cell, lowest negative potential right half cell. So right nothing but here, E right nothing but so 0 minus 0.44. Is it okay? So if you observe this, if you observe the construction of this galvanic cell, so very simple. So two half cells, both are connecting with salt bridge, and here this is zinc and this is Fe. Both are connecting with galvanometer. Is it okay? So here zinc undergoes oxidation and iron undergoes reduction. How can you know that? Which is having highest negative reduction potential, that is acts as a anode. Remember that, which is showing the less negative value, means in these two highest negative is zinc, that is why this is anode. Less negative is iron, that is why this is cathode. Is it okay? So E right value minus 0.44 minus, so here I am writing again minus 0.44 minus 0.76. So if you simplify, you'll get to plus 0.32 volts. That means zinc and iron combination, this much voltage you can create. Is it okay? Now what is our option here? Plus 0.32 volts. Now look at the next question. The EMF of the cell constructed from the following electrodes will be. So here again two electrodes given. Directly galvanic cell representation given. Zn, zinc undergoes oxidation, copper undergoes reduction. And I already said to you, before solving the numerical, observe whether they are SRP values or SOP values. If you observe this E naught Zn by Zn plus 2 given, that means this is SOP value, standard oxidation potential. E naught of Cu plus 2 by Cu means this is a reduction potential. That is why first to convert this value, E naught of Zn by Zn plus 2, then we can write it is Zn plus 2 by Zn equal to minus 0.011. Is it okay? Now E naught of Cu plus 2 by Cu equal to plus 0.077 volts. Is it okay? Now just now I said to you, in these two, which is highest negative value, zinc, that is why this is acts as a anode half cell, anodic half cell. This is cathodic half cell. Now if both are converting into their SRP values, then formula is simple. What is that? EMF of the cell is equal to E right minus E left, otherwise E cathode minus E anode. E cathode is nothing but here 0.077 minus 0.011. So if you simply get 0.088 volts. By this combination you can create this much of voltage of current. Is it clear? Then what is our answer here? 0.088 volts. Is it clear? Right. Look at the next question. This is a very important model. The value of E reduction of hydrogen electrode at pH equal to 10 is. So in this kind of numericals, observe here E reduction of hydrogen. First of all, reduction reaction of hydrogen. What is the reaction? 2H plus by taking 2 electrons, converting into H2. See that plus 1 to 0, oxidation number plus 1 to 0, reduction. Now if you apply the Nernst equation, what will get here? E equal to E naught minus 0.059 by N. N nothing but here 2 electrons into log product by reactant. Product is hydrogen gas, it is generally at 1 atmosphere. That means 1 by H plus whole square, because concentration of H plus. Now if you simplify, E equal to E naught value for hydrogen electrode, you know 0, minus 0.059 by 2 into log H plus power minus 2. Is it okay? Then what you get here, minus 0.059 by 2 into log x power m. You know this is the formula. That means we can write minus 2 log H plus. Okay, x power m nothing but m log x. Now if you observe here, 2 cancel, minus 0.059, okay, minus log H plus nothing but, you know, this is a pH, minus log H plus nothing but pH. That means minus 0.059 into pH. This is a formula in the case of E reduction. Is it clear? So this is the smallest explanation. Try to remember that, this is very important. Now pH value given. How much it is given? pH value, how much given? It is 10. pH equal to 10 given. That is, if we replace here 10, then we get minus 0.59 volts. Is it okay? So generally, half cells can show the negative voltage, but complete cells should not show the negative voltage. So as this is a hydrogen cell only, that is why minus is acceptable, no problem. Is it clear? Procedure, do you understand? Suppose if they are asking the E oxidation, just reverse the reaction, apply the process. You will get just plus 0.05 into pH. Very simple. Is it okay? Right. Look at the question number 180. Calculate the standard free energy change for the reaction. So here reaction given 2Ag plus 2H plus gives H2 plus 2Ag plus. And given that E naught for this Ag plus means Ag plus 2Ag, that means I already told you E naught of Ag plus by Ag, that means it is a SRP value is equal to how much it is, plus 0.80. Already you know hydrogen H plus by H equal to 0, means standard reduction potential of hydrogen is 0. It is very clear. What they are asking here, free energy. Free energy, what is the formula? Delta G naught equal to minus NF E naught. This is the formula. Is it okay? So N nothing but number of electrons involved in the equation. So in this reaction, in this cell, how many electrons involved? 2 positives, nothing but 2 electrons. That means 2 into F nothing but 96,500 coulombs into E naught nothing but, what we can write, E naught of the cell is equal to E right minus E left. Here right is what? Hydrogen. That means 0 minus, what we get here, 0.80. So then get minus 0.80. That means minus 0.8 multiply here. Is it okay? If you multiply and simplify, you'll get to 154.4 kilojoule. Is it okay? So direct substitution, simple explanation and very important model. Is it clear? So that is why, what is our appropriate answer here? So plus 154.4. Is it clear? Right. Look at the next question. The what is the EMF of cell given E naught A by A plus equal to 0.35 and E naught B plus 2 by B equal to minus 0.42. The cell has the electrode A and B in their respective electrolytes. Okay, so here some unknown electrolytes given, but whatever it is, their reduction potentials. First your observation is reduction potentials. Is it reduction potential or oxidation potential? A plus by A, nothing but it is oxidation potential. That is why what we take, E naught of A plus by A equal to minus 0.35. Similarly, E naught of B plus 2 by B, this is already given in the reduction potential only, that is why minus 0.42 you take as it is. So both are SRP values. Both are coming to the SRP values. Now EMF of the cell equal to E right minus E left. So I already told you which is left and which is right. Which is highest negative reduction potential, that is left. Is it okay? That is why what you get here, minus 0.35 minus 0.42. So if you simplify, we'll get 0.07 volts. Is it clear? Is it okay? So our answer is 0.07. So A. Is it okay? Right. Look at the next question, question number 181. The half cell reactions of the cell used in hearing aids. Okay, in hearing aids they are given. So Zn gives Zn plus 2. That means Zn2, Zn plus nothing but it is oxidation reaction. That means it happens in the left half cell. Ag2O plus H2O plus 2 electrons gives Ag. So Ag2O nothing but here oxidation number positive to 0 changes. That means it is the right half cell. So left half cell E0 value given, right half cell E0 value given. So just what is our formula now? E0 equal to E right minus E left. E right nothing but 0.34 minus E left nothing but minus 0.76. So if you simplify, you will get 1.1 volt. Is it clear? Direct formula. So that is why 1.1 volt. Similarly, see there the next question. So this is the textbook question. Electrode potential of Zn plus 2 by Zn. That means reduction of potential only. Is minus 0.76 volts and Cu plus 2 by Cu is plus 0.34 volts. The EMF of the cell constructed between these two electrodes is same formula, direct formula. E equal to E right minus E left. Is it okay? Here right nothing but copper, left nothing but zinc. The reason is the highest reduction potential shown by zinc. So that is why 0.34 minus 0 minus of 0.76. So if you simplify, you get 1.1 volt again. Is it clear? Same answer. But the cell is different, but answer is same. Now look at the next question. The voltage of a cell whose half cell is given below. Again here also half cell is given. Mg plus 2 to Mg minus 2.37, Cu plus 2 to Cu plus 0.34. The EMF of the cell will be. Here also same explanation, E right minus E left. So here if you observe that Mg plus 2 to Mg is a reduction potential. This is reduction potential only given. Cu plus 2 to Cu reduction potential only given. Again formula is what? EMF of the cell equal to E right minus E left. That means otherwise E cathode minus E anode. So here which is cathode here? Copper is cathode. So 0.34 minus what you get here? Minus 2.37. Is it okay? E right minus E left. So if you simplify, we'll get 2.71 volts. Is it okay? So 2.7. So option C. Is it okay? Is it okay? So once again observe here the voltage of the cell whose half cells are given below. So magnesium plus 2 to magnesium reduction potential given. Cu plus 2 to Cu also reduction potential given. EMF of the cell nothing but same formula. E right minus E left 2.71. Is it okay? Right. And this is another important model. The solution of nickel sulfate. The solution of nickel sulfate in which nickel rod is dipped in is diluted to 10 times. The potential of nickel is. So this is important model, diluted questions. So just imagine one half cell is there. In that it contains nickel sulfate and it contains electrode that is nickel. Is it okay? So generally within the cell only cell EMF developed. So here what is the anodic reaction? Nickel converting into solid converting into nickel plus 2 by releasing electrons. What is the cathode? That means sulfate. That means Ni plus 2 by taking electrons converting into nickel. So this process is going on. So because of the electrode and electrolyte differentiation, automatically potential developed. So as per the Nernst equation, what we can take? E0, E of the cell equal to E0 minus 0.059 by N. Here N nothing but 2 electrons involved into log product nickel solid by reactant nickel ions. Is it okay? So E0 minus 0.059 0.059 by 2 into log Ni plus 2 power minus 1, because this is a unity. Is it okay? Now E naught minus 0.059 by 2 into, so 0.059, if you simplify, what get here? E naught minus 0.02955, okay, into minus 1 log nickel plus 2. So if you simplify, if you multiply these two, E naught plus 0.02955 log Ni plus 2. Okay, this is the EMF of the cell. Now here one small explanation about the concentration. So we must be aware about the concentration. So nickel plus 2 concentration is equal to mole of nickel plus 2 by volume in liters. You know that M equal to M by V formula. M equal to M by V formula. Is it okay? Now here, from here, E equal to E naught of the cell plus 0.2955 into log 1 by 10 Ni plus 2. Why 1 by 10? Because 10 times diluted, they only sit in the numerical. Okay. Now, since if you consider this nickel plus 2 as 1, it is 1 by 10 times diluted. Is it okay? Now, if you remove this is as a unity, then what you get here? E naught plus 0.2955 into log 10 power minus 1. Then if you simplify, what you get here? E naught minus 0.2955. E naught minus 0. Near it is 0.03. Is it clear? So here 0.0 also there. We forgot that. So 0.02 double another 0.0. So from original value this much. From original value this much was removed. That means 0.03 times decreased. So observe here. That means it decreases by 30 MV. Okay, millivolumes. Is it clear? Do you understand the procedure? It is a very simple procedure and very important procedure for the objective point of view. Is it okay? Right. So these are the few models. So with few more models we will meet again in the next video. So by the time, do follow, do carefully, take care. Do watch my videos comfortably and give your valuable feedback. So we'll meet again. Subscribe it and share it. Thank you.